Okay, Math Models, this is Miss Reeves. I've been reading some of your notes on your paper that you don't know what to do, you don't know how to work these problems. Most of this should be review because this is Algebra 1. I'm going to go through and work a few problems from your packet and explain a few things. You should be able to finish this packet by the end of class today and grade it. I will try to make some videos here and there to help you out, but for the most part, this should be review. Okay, so if we're on the first page, we are looking at linear functions in slope-intercept form, y equals mx plus b. So number 5 says to begin with a line that has a slope of negative 2/3 and a y-intercept of 6. So the y-intercept is where we want to start. We're going to put a point on positive 6 on the y-axis. And since it says that it has a slope of negative 2/3, remember slope is rise over run. We're going to go down 2 spaces and right 3 spaces and put another point. And you can do this several times. So remember down 2, right 3. Down 2, right 3. So I can put points on all of those places, and that will help me draw a better line. Now this problem is asking us to write the equation in slope-intercept form. So since they gave us the slope-intercept form, this one should be pretty easy. Y equals, you always start with your slope, which was negative 2/3 x plus your y-intercept, which is positive 6. So y equals negative 2/3x plus 6. Most of you did a pretty good job about starting the problems on this page. Just make sure that you continue. Each of the problems here, they're having you change something from the problem before, graph it, and then rewrite the equation. Okay, on the next page, they are giving you information about a linear function again. They want you to write the equation in slope-intercept form, and then they also want you to write it in standard form. So let's look at number 2. Number 2 says that this line contains the point 4, -1. So I'm going to plot that point. So that's to the right 4 spaces and up 1 or down 1 space. So there's my point 4, -1. It has a slope of 3/2. So slope is rise over run. So we're going to go up 3 spaces and right 2 and put another point. And I'm going to keep going. So I'm going to go up 3/2. Put another point. If you want to go in the opposite direction, instead of going up, you're going to go down 3 and then left 2. Make sure that it follows the same pattern. Okay, I'm going to draw my line. Sometimes it's easier to continue the slope pattern so that you can actually see where it winds up crossing the x-axis. So I was really close on my line here, but from that last point, if I went down 3 and left 2, you could see that this one crosses at -6 right there. So that's helpful in me writing this equation. Okay, because for the equation, I need the slope and the y-intercept. We know that the slope is 3/2. X, and then I just found out that it crosses at -6. That's the y-intercept. So I'm going to put -7, not 6. So I'm going to put -7. Okay, now what they want me to do on this problem is to transform it from slope-intercept form into standard form. So standard form has x's and y's on the left-hand side. There aren't supposed to be any fractions, and they don't want the x coefficient to be negative. So let me show you how to do that. We're going to take our function that we already have, and first thing I want to move my x's to the left-hand side with my y. Since it's a positive 3/2 x, I'm going to move it over. It becomes a -3/2x plus the y that was already there is equal to the -7 that stays over there also. So one thing I need to do is get rid of the fraction. So in order to get rid of the fraction, I'm going to multiply everything in the equation by 2. Now also to get rid of the negative that's on the top, I want to multiply everything by a negative. So I'm going to distribute the -2 throughout everything in the problem. That's going to clear the fraction and get rid of the negative. So when I do negative 2 times negative 3 over 2, that's going to become positive 3x. When I do negative 2 times positive y, that's going to be minus 2y. Negative 2 times negative 7 is going to become a positive 14. So look how nice and neat that is. No fractions, x's and y's are on the same side, and x is positive. So this is the equation in standard form. 3x minus 2y equals 14. Okay, so you should be able to finish the problems on this page. Make sure you use the information that they gave you, find the slope and the y-intercept, write that equation down, then transform it into standard form. Okay, on the next page, I'm not going to work these examples for you, but I want to show you a few things. First thing, parallel lines. So on number 4, it asks about a line that is parallel to the one that is given. So one thing to remember with parallel lines is that they have the same slope. They rise and run the same amount. So if you're trying to write a new equation for another line, then you're going to use the same slope that they have in the other equation and the other important information that they gave you as well to write that equation. Okay? Now the other thing on number 5 is when they talk about perpendicular lines. Perpendicular lines do not have the same slope. They have slope that are negative reciprocals. And the way I remember it is that you're going to flip it and change the sign. Okay, so if I'm looking at the slope that they gave me in this problem, which is a 3, that's the same as 3 over 1. So if I want the perpendicular slope, then I'm going to take that 3 over 1 and flip it, which becomes 1 over 3. And it was a positive 3, so now this becomes a negative 1 over 3. So you're going to use that negative 1 over 3 slope and whatever else they gave you in this problem to go ahead and solve that one. Okay, on the next page we're looking at x-intercepts, y-intercepts, and zeros. So something to remember here, the x-intercept is where it crosses on the x-axis. The y-intercept is wherever it crosses on the y-axis. So for problem number 1 here, our x-intercept is negative 8, which is the same as the ordered pair negative 8, comma 0. Our y-intercept is at negative 5, which is the ordered pair 0, negative 5. Something to always remember that when you have an x-intercept, the y will always equal 0. And when you have a y-intercept, the x will always equal 0. So whatever the intercept is, the opposite letter is a 0. And then the last thing on this problem is that the 0 of a function is the same as the x-intercept. It's also known as a solution and sometimes called a root. So lots of different names for the same thing, but the 0 in this case is negative 8. Okay, so you should be able to use that information whether you're given an equation or a table, find the x-intercepts and the zeros. If you're given an equation, go ahead and put that equation into your calculator and then go to your table or graph it and find those things. Okay, let me give you some pointers on the very last page here. This says that the graph represents the purchase price of a charm bracelet at Joni's Jewels. So one thing you always want to look at is the initial point. So that very first point over here on the graph, or the y-intercept, is what the value starts out to be. So this is when there are 0 charms, what the price of the bracelet's going to be. So it looks like this graph on the y values is going up by 2s. So that initial point is going to be $6. Okay, so that's an initial value. You could look and talk about that's without any charms. That is the y-intercept, several different things. Okay, then the next thing we need to figure out is what is the price per charm. So most of the time when we're doing slope, we just count the boxes. But in this case, we can't count the boxes. Not every box is going up by ones. So remember, we want to find two intersections. So I like the first point that we already chose, and I'm going to pick another point out here, always looking at an intersection for 2 points. And I need to figure out how much we're going up and over. So if I started at 6 and I go up to 18, so I know 18 minus 6 is going to be 12. And then I went over 3 spaces. So remember, slope is rise over run. So 12 over 3. So in this case, this means that the slope is 4. Now for this problem, that means that the cost per charm would be $4. So the cost per charm is $4. Okay, now they're going to take and they want you to change things in these other problems and maybe keep the initial cost the same, but change the cost per charm and then graph it. So you'll have to use this information that you were already given that we just found for the first one and then find out what these other problems will be. Hopefully this will help you finish this packet. Remember, you are going to grade it at the end of class today.